All right, so now we're continuing our discussion in Chapter 3. So we're looking at Section 3.3, which is titled Summaries for Skew Distributions. So previously we looked at looking at some summaries for distributions that weren't skewed. Now let's consider what do we do if we have a skewed distribution. So what we want to look at is another measure for center, the middle point, what we'll call the median, and then also look at a measure of horizontal spread or variability, which we're going to look at as IQR, the interquartile range. Right. So next slide, I just want to talk about what the median is. Right. So the median is where we take all our data values and arrange it from smallest to largest, and you find the value right in the center. Right. So it separates your data in half. Right. So actually, I want to show you an example of this in everyday life, right? So if I go to Marion Tech's webpage, and if you click on in the top right-hand corner, there's this guy with a yellow shirt on, right? If you click on this, this will open up Career Coach. So Career Coach is a website that you can use to do a search on careers and find some data about the career. So like what kind of training it takes, what's the median income, and so forth. So I'll just type in, I don't know, medical laboratory assistant. Right. Okay, so medical and clinical laboratory technician. Right. I believe that's the job. Right. Yeah, that's what I was looking for. So you can look at this through the website. This information in HTML format, but I personally prefer to look at the download PDF, right? And what's great about this website, if you notice, I can set a region. So this is all local data, right? This is up to 50 miles away from Marion, Ohio. So when we look at places like the Bureau of Labor Statistics, that's national data, and it has a lot of variability, right? So if you want to look and see, is this career good for this area, you want to look only at that region. So if we download the PDF, then we get to this chart. So here is where it says the median, right? So the median is 1966 an hour or 41,000 a year, right? So if I go back to my notes, so what we found is that the median is what was it, $41,000, right, for medical laboratory technicians in this area. So what this means is if I ranged all my data from smallest to largest, right? Here's like my number line, right? Then right here, this value, 41,000, this splits my data in half, right? So in essence, what this means is that 50% are going to be to the left of 41,000 and 50% are going to be to the right of 41,000, right? So I have 50% of my medical laboratory technicians are over here making in this income range, and 50% that are also in the region are making above this number, right? So it separates separates your data, right? So this is another way to find to talk about the center, right? And we're going to find that well, we already know that the mean works well for if we have a distribution that's not skewed. But if we have a distribution that's skewed, this median value we're going to find works out a lot better, right? It talks more about the typical value, what we typically expect in that data set. Right, so here's the median. So we're looking at this example that we've looked at before about New York residents. So this red line, right, that's in the graph shows the median. So it's telling us the median here is 25.2, right? And that's in thousands of dollars. So that would be $25,200, right, is the median income. So in New York, 50% make less and 50% make more from this time frame, right, where the data was collected. I'm not sure what year, right? So about half have above 25,200 and about half incomes are above 25,200, right? So half are below, half are above. Right. So this next slide, we're using the same data, right? We have the same histograms on the left and right. But on the left one, this triangle, red triangle, is identifying the mean, right, x bar. And this is identifying the median, right? And these are listed here. So you can see that a mean of, this would be $42,100, right? Compared to $25,200, those are pretty drastic, right? Talk about the middle value, right? Those are pretty drastically different salaries. So the mean here would be off in this case, and it doesn't really speak to the typical value, right? There's not tons of people at that area, right? That wouldn't be considered what we call a typical value, or a value that we would expect to happen more often than others, right? But this median value is a better indicator for a skewed distribution, right? So that's on the next slide here, right? So the median, again, is the middle number. How to find this? You arrange all the numbers in order, and then you find the number that's in the middle, right? So if you have an odd number, you're going to have one number directly in the middle. But if you have even numbers, then you want to average the two middle ones, right? Right, so just a note here, we want to think of the median as the middle point, right? So median is the middle, and this is a good measure, as I've said, if we is a good measure of a typical value for skewed distributions. So if we have a left skewed or right skewed, this is a good value to use. So here's an example. It says, suppose a sample of prices for 1 gallon of regular gas at 10 different gas stations in a neighborhood in Austin, Texas, is taken on one full day in 2013. We want to find and interpret the mean, right? So we still have these gas prices from Austin, Texas, right, that we've been working with. So in order to find the median, we take our values here, and then we want to put them in order from smallest to largest, right? Which has been done, right? So we took all the numbers and put the smallest here, and then keep going up until we get to the largest, right? So this is the min, and this is the max, right? The minimum is the smallest value in your data set, and the max is the biggest value in your data set, right? So it turns out that we have two middle numbers, right? So if I cross these out one at a time, right, until we meet in the middle, we will get 2 in the middle, right? So I want to find the number that's right in the middle of this. So to find a number that's in the middle of two numbers, we average them, right? So we add them together, divide by 2. So here's what we're doing, right? To find the median, we take the two middle numbers, 2.99 plus 2.99, we divide them by 2, and we get 2.99, right? So this is the median. So here's an interpretation of the median. So it says the median price of 1 gallon of gas at these gas stations in Austin, Texas was $2.99 on this particular day, right? But we could say something even more, which I think is a more powerful interpretation, right? And that's understanding the definition of a median, right? So we could say something to the effect of, let me type here, right? I might say something like that 50%, so let me make this larger for you. So we could say 50% of gas prices in Austin, Texas on a particular day in 2013 were below $2.99. Right? And we could say, and 50% were above $2.99. Right? So I think this just helps visualize this a little more, right? Have a better interpretation of the meaning. So we can find this using the graphing calculator, right? And I will do an example of this in a moment. Right? So then another thing that we want to look at is being able to measure the spread, right? So if we think about a little bit before, when we were talking about finding the mean, that center value, when we measured the spread, we used standard deviation. But if you remember, standard deviation uses the distance from the mean, right? So it doesn't necessarily make sense to talk about the standard deviation with a skewed distribution as much, right? So we need a measure of spread that's better related to the median. So what we use is called the IQR, or the interquartile range, right? So first, let's talk about the range, right? So the range is the difference between the largest and the smallest, right? So we need to talk about the range and quartiles before we can show you what the interquartile range is. So a range is the difference between the largest and smallest values. So in other words, the range is equal to the max minus the min, right? So we take our maximum value minus the minimum value, right? And I showed you above, if you put your data set in order from smallest to biggest, then the number on the left is the min, and the farthest number on the right is the max, right? So here's just an example. We have a group of 8 children, have the following heights, and notice that's already in order from smallest to biggest. So this value, this is my min, and this is my max, right? So to find the range, we subtract the maximum minus the minimum, we get 23 inches, right? So that's known as the range. Right. So the next thing that we need to do is to think about quartiles. So we're told here that we need to divide the distribution into fours, so each quartile will contain 25% of the data. So, for example, here it says the dot plot shows the distribution of weights for a class of introductory statistics students. The vertical line slices the distribution into 4 parts. So each part has about 25% of the observations, right? So we want to find where these lines are, right? So this red line is the median, and these 2 blue lines are quartiles, right? So we actually call this quartile 1, quartile 2, or excuse me, this is quartile 3. This is actually quartile 2, which is also the median, right? And over here, we would have my min, and over here we have a max, right? Right, so we're told here 25% of the weight are between 101 and 121, right? So we're talking about this data here, right? We have 25% of our data in between there. So the interquartile range is the middle 50% of the data, right? So what we're talking about is this middle 50% here, right? So 25% on this side, 25% on this side. This is the IQR, right? So that's the range between those is the IQR. So here's still using the same example of the dot plot for our weights for an introductory statistics class. Right? So the IQR in this case, so we're saying this is 160 and this is 121, right? So if I take 160 minus 121, then I get 39 pounds, right? So that's the IQR. Right, and we can also get this using the calculator, which again, I'm going to show you how to do that in a minute. Right, so here is finding the interquartile range. And so here's an example, and we're asked to use our calculator to find the solution. So let's bring up our calculator. So remember, the first thing I'm going to do is I want to go to second and memory, so hit the plus sign, and I want to go to clear all lists, right? And again, this just makes it helpful just to get rid of all the data we put in before. So then now I can go to the stat menu, right, which is here. Then I want to go into edit, and then I need to enter my data in first before I do anything, right? So we have 48, 48. And notice I'm just entering 48 instead of 48.0, right? That means the same thing, right? So we don't have to put the .0 if you don't want to. 53.5, and then we have 54, 60, 62, and 71. Right? So I think I have all those entered in, right? So it asks us to find the interquartile range for distribution of the children's heights using your calculator, right? So what I would do, we'll go to second quit. Then I'm going to go back into the stat menu, and we're going to go over to calc, and then the one variable stats, so option 1. So hit enter. We're telling our calculator we want list 1, right? So I leave that the same. So I'll go down here to calculate and hit enter. And there we go, right? So remember, this is the mean. Here's the sum of all my x values together and so forth, right? This SX, right, that's my standard deviation. The N is how many values I have, right? So if we scroll down, it will have the minimum and the maximum listed for us. And then also this quartile 1 and quartile 3, right? So remember, we're splitting our data into 3 parts. And the IQR is Q3 minus Q1, right? So the IQR is Q3 minus Q1. So let me do split screen here. There. That way I can see it. So IQR, while I'm writing. So IQR is Q3, which is 61, minus Q1, which is 50.5. Right, so you can do that in your head, or if you want to type it in, that's fine. We can do 61 minus 50.5. We get 10.5, right? So 10.5. All right. So if we scroll down, there's a solution for this example. All right. So also, I want to make sure that you know how to do this by hand also. Right, so let's do this by hand so you can have a better understanding of what we're doing also. So I'm going to go back to the stat menu and edit, just so I have the list of my data points there. So my list of data points were 48, 48, 53, 53.5, 54, 60, 62. Is that it? Let's see. Oh, one more. 71. Right, so we have 1, 2, 3, 4, 5, 6, 7, 8 data points, right? So n equals 8. Right? So n being the number of data points you have. So remember, what we want to do is, so think about this. If you had a candy bar and you want to split this in 4 equal pieces, right? The easiest way to do that is to cut it in half, and then cut each of the halves in half, right? That would be an easier way to make 4. So that's what we're essentially going to do with our data set, right? So the median is simply just cutting our data in half. So since I have 8 data sets, right, I'm going to want 4 on each side. So this line here would be represent my median, right? Or we call it Q2, right? Quartile 2. But notice there isn't a data point exactly in the middle. So to find that, we want to find the middle value in between 53.5 and 54. So to do that, we would need to take 53.5 plus 54 and then divide that by 2. Right? So if we take 53.5 plus 54 and then divide that by 2, I get 53.75. Right? So that's this value here, 53.75. Right? So then now I want to split, so this part we can call like my lower half. Right? And this part like my upper half. So now I want to split each of these directly in half, right? So to split the lower half, basically what you're doing is you're only worried about these data sets in yellow, right? So we're ignoring everything else. I want to find the median of this data. So the median would be right in the middle, right? So again, I don't have a number directly in the middle, so I need to average these. So if I take 48 plus 53 divide by 2, I'll find that, right? So 48 plus 53 divided by 2, we get 50.5. And then we need to do the same thing with the upper half, right? Find the middle value in between here. So we find the number in the middle between 60 and 62. So if we average those, you should get 61, right? So then this is Q1 and this is Q3, right? And over here is my min, and this is my max, right? So then the IQR, the interquartile range, would be Q3 minus Q1, which is 61 minus 50.5, right? Which we got to be 10.5, right? Before, which is exactly what we had up here, right? All right. So the next thing I want to do is show you how you can also calculate these using R. So if I just pop open R, so I'm going to go to edit and make the screen bigger for you, or the text. So let me do this split screen again. So since we only have very few numbers, I'm not going to upload an Excel file into R. So I'm going to go to stat and get my data again, right? Because I already have this typed in. So if we're not uploading a file into Excel, we don't have to worry about working directory. I can just go say data, let my data be equal to, and then use the C command. So the C command allows us to enter in data with comma separated, right? So 48, 48, 53, 53.5, and then we have 54, and then 60, 62, I think there's one more, yeah, 71. Right, so I think I have that right? So let me double check, make sure I typed it in right. 48, 48, 53, 53.5, 54, 60, 62, and 71, right? Good, so we're good to go. So we can just hit enter, right? We still have to attach the data, right? So I say attach data. Or excuse me, so I'm noticing here I'm getting an error. So it says it only works for lists, so I don't have to worry about attaching the data then, right? So only if we're uploading an Excel file, right? So what I can do is I can just do summary of data, and what this does is this tells me my what we call the 5-number summary plus the mean, right? So the minimum, the first quartile, the median, the third quartile, and the max, these are all referred to as the 5-number summary, and we're going to explore this a little later when we look at box plots. But this gives me all those values for me, right? So again, to find the median, or excuse me, the IQR, the interquartile range, we could take the third quartile minus the first quartile, right? And if you remember, so if we go back to stat and calc, one variable stats, go down to calculate. So just one thing to note here is that our calculator and the way that we calculated the quartile, we got 50.5, and inside of R, it's telling us it's 51.75. With Q3, it's 61, and R is telling it it's 60.5, right? So there's a little difference here, and that's okay. They're both actually right. So one thing that might be hard to wrap your mind around is that statisticians have different ways of calculating things and different methodologies, right? So both of these are correct. They're just calculated a little differently, right? But they're really close, right? In statistics, we need to be exact, but it's not so crazy exact as mathematics. But even in a typical mathematics class, people have different discrepancies on different things, right? So for example, the definition of mode, right? Some statisticians believe that if you have two numbers that are the most frequent, that there is no mode in that case, right? Where some mathematicians or statisticians would include both, right? So there are some differences in definitions and what people believe to be true, right? So you just have to keep all of those in mind when you're looking at calculations, and when you're talking about your calculations, it's important to show both, right? But for this class, I want you to be able to, like, if we're doing an R assignment, obviously we're going to use the R values, right? But if you're doing an exam for me, I would want you to find the Q1 and Q3 the way that I showed you, and the calculator does the same way, right? All right, well, that's all I have for this video. I'll see you guys later.